In this screencast, we're going to show you how to figure out the charges on any element when it becomes an ion. So we've learned that the elements in the periodic table all have protons, neutrons, and electrons, and the protons and neutrons are in the center of the atom, and the electrons are in the cloud outside of the nucleus. And depending on what element you have different numbers of electrons. So you can look at the periodic table and determine the number of electrons in its outer shell. Now, the valence electrons are the electrons in the outer shell, so we need to remember that. Okay, and the number of electrons will depend on both the column and the row that the elements are in the periodic table. So for instance, if we look at hydrogen right here, hydrogen has 1 electron and helium over here has 2. So we know that helium does not necessarily follow the rules of its entire column. It's a little bit different, but it is still considered to be a noble gas. So when we're looking at valence electrons, all of the elements here in this first column are all going to have similar number of electrons in its outer shell. So what happens is hydrogen has 1 valence electron, and so does lithium, and so does sodium and potassium. Let's look at lithium. Lithium, if we look at it, it has 3 protons and 3 electrons. So in the center, we have our 3 protons, and we have 4 neutrons, and around it, we have 3 electrons. So the first shell can have the 2 electrons, and then the next shell can have 1 electron. So we know that in our outermost energy level here, we're going to have 1 electron for lithium. We're going to have 1 electron for sodium, potassium, rubidium, cesium, all that entire column. So they're all going to have 1 electron. When we look at beryllium, we have 2 electrons. We are not going to worry about the transition metals because they have multiple oxidation states, and that means that they can have more than 1 charge possible. So we're not going to worry with them. We're going to ignore them for right now. When you come over here to boron, boron is going to have 3 valence electrons. Carbon has 4. Nitrogen has 5. Oxygen has 6. Fluorine has 7. And helium has 2. But the rest of them all have 8. So depending on where the element is in the periodic table, you can look at it and identify how many valence electrons. Now remember, the valence electrons are the ones that are free to be gained or lost when we're forming bonds. All right, remember the octet rule has 8 electrons in the outer shell, unless you are hydrogen or helium, and then you need 2. We do this for stability, and so that we can find something to gain or lose electrons or share them with. Hydrogen has 1, beryllium in his column has 2, boron has 3, carbon's column has 4, nitrogen has 5, oxygen has 6, fluorine in its column has 7, and for the most part the noble gases have 8. So when we are trying to achieve the octet rule, you are always looking to see what can I add to or subtract from to have 8. All right, so remember, electrons are negative, and when we have an atom, our electrons and our protons are equal, but we're going to become an ion by gaining and losing our electrons. So if we're gaining electrons, we're adding extra negatives, and if we're losing electrons, we're going to be becoming positive and having less electrons. So this first column all has a valence electron structure of 1 electron in its outer shell. So would it be easier to gain 7 or lose 1? And the answer is if you lose 1. So by losing 1 electron is leaving the situation. So we would be becoming a +1 charge for that whole first column. Likewise, in the second column, we have 2 valence electrons, and so we would be having 2 electrons leave because it's much easier to deal with 2 rather than 6. So in that situation, we become +2. over here with the noble gases, they have 8, so they're perfectly stable and they are not going to gain or lose, and therefore they don't really have a charge. You can force them to have a charge, but they are not going to have typically have any kind of charge that we're going to be identifying. Now, fluorine in its column, the halogens here, they have 7 electrons in their outer shell. So is it easier to lose all 7 of those electrons or gain one more? And so the answer is it would be easier to gain 1 electron. Remember, electrons are negative. So if we gain an electron, we're going to become -1. Oxygen in its column have 6 electrons. And so would it be easier to lose those 6 or gain 2? And the answer is gain 2. So that becomes -2. If you follow the pattern, we get -3 over here and +3 over here. Now, carbon and the other elements, they are really in the middle. They have 4 electrons, so it is equally easy to lose 4 electrons as it is to gain 4. So our charges here will become plus or -4, and it really will depend on the situation, and we'll have to have more information before we can decide if it's a plus or -4. So depending on what element you have in the periodic table, for instance, if you have silicon, you just look in the column and we'd say plus or -4. If we have strontium over here, we'd say it's +2. You're going to be able to look at the periodic table, identify what column it's in, and you should be able to understand what its charge is and be able to figure it out.